Okay, let's write down all our formulas so you've got them in one spot. And when you make your note card for the test, I would come right to this section and make sure you've got all these formulas down. So we started with arc length. And our letter was S. And our goal to get arc length, our idea to get arc length was the fraction of the circle we were using times the circumference. So it was fraction of the circle times circumference. So that was, to get the fraction, it was our theta divided by either 360 or 2 pi, whatever matched our angle measure for our pi piece, and then times 2 pi r. Okay, you were also given in just this last section another formula to get arc length that was RWT. So now you've got two formulas for arc length, depending on what's given to you. Okay. Then we move into velocities. Linear velocity. And linear velocity is like miles per hour, inches per second. So you've got some kind of linear distance over time. Distance divided by time. And because we're talking about things moving in a circular pattern, our distance is our arc length. So our distance is S divided by C. And S is this stuff up here, your fraction times the circumference, and we'll divide all that by time. And we also had a second formula, which was RW. So depending on what information is given, depends on which formula we're going to use. And then we had angular velocity. Is always, I mean, we talked about angular velocity could have been degrees per second or degrees per minute, but they don't do anything with degrees with angular velocity. It's always considered radians over time. Oh, I forgot my little letter. So W equals theta over T. So only one formula for that. We did have one other formula for area, but the area doesn't come into play with any of these linear velocities. That's why it's not in this section, so I'm not going to bother putting it down here. Okay, solve story problems all day. Are you ready? And here we go. Number 1. Oh, yeah. We have a tire with a radius 15 centimeters. It rotates 40 times per minute. Can you find the linear velocity? Now it's all about going back in and grabbing each piece of information and saying what it's telling us. Radius and time are usually our easiest ones. So obviously radius, we got 15 centimeters. So there's our R value. This rotating 40 times, making 40 complete revolutions per 1 minute, okay? I don't have anything up here that's rotations, but it's very close to something. What can we figure out knowing the rotations? We can figure out the degrees, so we could get the central and the theta, or we could turn that into radians, either one. Our best bet is going to be, well, it doesn't really matter too much. Let's go, so I'm going to call it almost theta, because we can turn it into radians by doing one little trick. Then we got per minute, so 1 minute is our time, and then we're finding linear velocity. What symbol is linear velocity? Big V. So, if we look at linear velocity, do we have enough to find the x? And do we know the t? Well, the s requires us knowing the angle measure and r. And we have that, angle measure and r. Well, we're going to have the angle measure. So, I need to get this to theta. So my almost theta is 40. How do I get that into theta? We can go degrees, doesn't really matter. Which way do you want to go? Because it's 40 rotations. Let's stick with radians. How many, Jimmer?
Multiply by 2 pi.
2 pi. Best bet to stick with radians. So if we've got 40 rotations, that's telling me it's passing through 80 pi radians. So now that we've got r, we got theta, we got t, we can find v. So our s is the fraction of the circle, which is going to be 80 pi divided by 2 pi. Oops, I got that too high, that's right. Times the circumference, 2 pi times the radius, 15. So see, everything I did was right here. I figured out the s. I did the 40 or 80 pi divided by 2 pi and then times by 2 pi r. So all of that was to get f. I still got to divide by t. And my t is per minute, that's 1 minute, so it doesn't really change anything. Let's just simplify. So we multiply and put a label on it. Sometimes it's the labels that are the hardest. If we want to stay exact, what is 80 times 15? 1,200. And because this is linear velocity, I need a distance per time unit. What's my distance unit? What in here was a distance? So it would be centimeters per minute. Okay, go for another one. Number 2. We've got a wheel that's making 80 revolutions per minute. Radius is 6 centimeters. Can you find linear velocity in centimeters per second? Okay. The problems are going to start to get a little tricky. Do you see any red flags in this problem? Ben? Yeah, you've got a minute unit here and a second unit here. That's a little red flag. We're going to fix something. The centimeters are okay. So, let's go back. 80 revolutions. We just had this. We can get the number of radians from revolutions. So we're going to call that almost theta. I gotta fix it. Because I want my answer to be in seconds, this per minute, I'm gonna call that almost my time value, because I gotta fix that too. And then we've got our radius. And we're looking for big V. So we're going to be good to go with the same formula we just used after we fix the theta and the time. So theta fixed off to the side here. If it starts out 80 revolutions, multiply that by 2 pi to get your radians. Our time we're starting out with is 1 minute per minute. But we got to fix it so that I end in seconds. So what's my 1 minute going to change to? 60 seconds. So we're going to be using 60 seconds in the formula. So we go right into the formula we just had. Big V equals the arc length divided by time. So arc length is the fraction of our circle times circumference divided by our time value. The fraction of our circle is, it's not really a fraction, it's multiple circles. 160 pi divided by, what do I divide by to get what fraction of a circle? 2 pi. Then we multiply by circumference, 2 pi r. R was 6. And we got to divide all this by our time. So this is fraction times circumference, divide by time, 60 seconds. Get rid of a 10, get rid of a 6, oh, I got to cancel away. I got 16 pi. Anybody else?
Good.
16 pi what? Yeah, they gave you the label this time, centimeters per second. Okay, we've got, tell me what this is. See how good my drawing skills are. What does it look like?
Spindle of like yarn.
Thread, yeah, I'm going for thread. Yep, spool of thread. Spool of thread. You don't have to draw the picture if you don't want. You can say you got a spool of thread, whatever you want to. Okay, the spool of thread, as it's going through the machine, it's moving at 59.4 centimeters per second. So every second, about 60 centimeters of thread is coming off that spool. Okay? It makes 152 revolutions per minute. Can you find the radius of that spool? Okay, and the first thing I want to do on these problems is look for red flags. Do we have any red flags? We've got seconds here and minutes here, so we'll take care of that. I think that's the only red flag. So, what is this 59.4 centimeters per second? What letter would we call that? Centimeters per second. Ben? It would be big V, linear velocity, like miles per hour, centimeters. This is a big V value. Because we've got to fix that time, we're going to chop this up. Again, I've got revolutions. We call that almost theta, because we can get an angle measure out of that, how much it's spinning through. And because my velocity is in centimeters per second, I would want my time value to be in seconds. So we're going to call this almost t. And then r is what we're looking for. So we got to fix the theta and fix the t, and then we can plug and chug. So theta 152 revolutions. Every revolution it passes through 2 pi radians. Every time it turns 360 degrees, 2 pi radians. 304 pi radians. Time, 1 minute. We got 60 seconds. Now we're ready to go. So we know big V this time. So big V equals S over T. Big V is 59.4. S is your fraction times circumference. The fraction is our 304 pi divided by 2 pi. Our circumference is 2 pi r, and r is what we're looking for. So we're going to divide all that by our time of 60 seconds. So now it's your good algebra skills. Definitely cancel the 2 pi's. By going into radians, that just makes the formula a little bit easier. I think I'm going to times by 60 at this point. Get rid of that fraction first. Help me out on that number. 3,564 equals, the only thing I have left over here is 304 pi times r. Divide by 304 pi. You're going to want to be careful here. What are you going to need on the calculator? You have to have parentheses. Even though it looks like 304 pi looks like 1 unit, if you type it in just like that without parentheses, it does. 3,500 divides by 304, gets that answer, and times it, multiplies that by pi. Gotta have it in parentheses so it sees this chunk as what you're dividing by. So about what is the radius? 3.72? 73. What unit? Centimeters.
Short.
Yeah.
I don't think you can hold that much strata.
Oh, sure. There's thousands of yards on this little spool. I don't know how many yards are on
It's
there.
gonna run out fast. It's small.
Okay, one more. Got a train go around a corner. I should say at least one more. I got a couple more I could probably go into. I got all kinds of stories out. Okay, let's go. We got a train track coming into a corner. Train track. It makes this big corner. And go straight. Alright. However they engineer that, I don't know. Okay, but the corner is a 40-degree angle. Okay, the train is moving at 30 miles per hour. Can you find the time needed to travel around the curve? And we're just talking about the front of the train, not the entire train. We need to know how long the train was in order for the whole train, but just the front of the train. How long does it take the front of the train to hit the curve and get to the end of the curve? So that's the time. And we need to know one more piece. This is an 1,800 foot radius. Okay, any red flags anywhere? Yeah, we got feet here, miles here. The time, it didn't say find it in seconds or anything, so we can fine with hours. Alright, so let's see what we've got. What is this 30 miles per hour telling us? What letter? Big V. The 1,800 feet. It's our radius. We're going to call it almost radius because we've got to fix it. The 40 degrees. That's our theta. We don't have to fix it because we can leave it in degrees. If you wanted to fix it, you could, but you don't have to because we've got a formula that uses degrees. And we're looking for the time. So the only thing we're fixing is the radius. If it's 1,800 feet, what do we want to convert it to? Miles. What part of a mile is it? So how many feet in a mile again?
5,200.
So if we got feet, so 1 mile, 5,280 feet. Which way you could think of your little T box here. Where does the 5,280 have to go? On the bottom, 'cause it's got to cancel. 5,280 feet, 1 mile. So if you take 1,800 and divide by 5,280, if it's a decimal that runs on, kick it back to a fraction. 15/44 miles. Okay, now we're ready. F/T. So we substitute big V is 30. S is our fraction times circumference. Our fraction is 40 out of, what's my bottom this time? 360 because we're in degrees. Times 2 pi. R is 15/44. I'm going to get stuff lined up here so everything stays lined up. And then we got to divide by time. Okay, what do you want to do first? Adam. I multiply by t to bring that over there too. Good choice. So times by t. So we'll have 30t over there. Those are gone. So 30t equals, and then in here, probably just multiply all your tops together, then multiply all your bottoms together, and grab a decimal there. I could have reduced a little, but you're still going to have to pick up a calculator. See, are we multiplying pi in or leaving it out at this point? Let's multiply it in, so we'll get a decimal anyway for t. What'd you get? Anybody?
237.
Before you divided by 30?
4.
Okay, so point, what'd you say?
I got 0.23809.
Alright, anybody else want to verify? Yes, okay. And then it's just a matter of dividing by 30. Remember, this is going to be how many, part of an hour. So an obnoxious number. How much of an hour is it?
0079.
0079 or 0? 0079. Hours. Okay, good. Yeah.
You generally got the 0.23.
Yep, this is just multiply 40 times 2 pi times 15 in parentheses. So that does the whole numerator. And then divide, and in parentheses, 360 times 1 times 44. Just have parentheses around your whole numerator and around your whole denominator. Anybody else? That's pretty much the same. Let me see if I got anything different. Oh yeah, see how fast this Ferris wheel moves. Yeah, I think I made this one up myself. Because I don't think they actually move this fast. What number am I on? 5? Okay, we got a Ferris wheel. I think I know why, because dang, I got the diameter really big. Ferris wheel, diameter. How big do you think a Ferris wheel is? Yeah, like across. Give me a good estimate, because we're going to make up our own. I got way off here. There's no way. Mine's right.
30 feet.
I would have said 40. Yeah, 30, 40. We're in agreement there. Let's go 40 feet. Let's go 40 feet. Makes... How many times do you go around in a minute? 3? 3 times a minute a lot?
I'd say 2.
Go on 3. 3 revolutions.
Yeah, that thing's cooking.
Is it? 3 times in a minute?
Yeah, you make like...
You go kind of fast. I don't think 3 in a minute's too much. Can you find the linear velocity in miles per hour? Because that means something to us, miles per hour. Okay, any red flags? We got minutes and hours. There's one red flag. Anything else? Anything else? There's another one. Miles in feet. There's another red flag. And we got diameter. So that's got to get fixed twice there. Because diameter. We need a radius. So this is almost our radius here. Revolutions, almost our theta. And per minute, that's almost our time. So everything's got to get fixed. So, let's go radius first. Radius. First we got to cut it in half because this is the diameter. So we got 20 feet. And then to kick it into miles, divide by 5280. Cancel off a 0. 1 over, that's half of 528. 250.
1264. It's 1 over 264.
264. So that'll be miles. Theta, 3 revolutions, multiplied by 2 pi. That will give us 6 pi radians. And our time we have is 1 minute. We've got to fix that to get it to what part of an hour is 1 minute. So, let's go, what do we got? How many, 60 minutes in an hour? So, 60 minutes, 1 hour. So it's going to be 1/60th of an hour. Okay, everything had to get fixed there. Now it's just plug and chug. Okay, so we're finding big V. So S is our fraction. 6 pi divided by 2 pi. Times 2 pi r. divide by our time. Get rid of that. Now it's calculator work, so we'll have 6 pi over 264. How do I divide by 1/60th? 60 over 1. Whatever that, how fast is our Ferris wheel moving? Only 4 miles per hour? That's pretty slow. 4.28? We did all exact. I'll Google it, see how fast they move. I don't think it goes that slow, does it?
Yeah. Those things like go like this. Like they turn like that slow.
Really?
Unless you
I'm
like-
curious. Curiosity's piqued.
Unless you get the crazy carny that just like jams the thing forward.
Let's
Just goes
see.
flying.
We need a...
That guy that lives with us. Contact.
let's
Crazy.
October 30th. Here we go. Page 134.
That was weird. That's crazy.
Okay.